Okay. Can you read? It may be a little hard, but sorry about that. I'll tell you what. I'll do a magnifier when needed. Okay. So I've created an empty project. If you can successfully create a new project where you specify the directory, you specify the name and directory and confirm a few steps, and you get to this point, then your software installation is totally healthy. Typically you won't face any other serious issues that will require you to reinstall the project. Aaron went through hassles and had to reset the Windows back to factory setting before an error disappear and can install the software. All right. So the first thing in the new project is to create a library. So a library is what? A library is a shortcut in the SAS format that points to a directory on your local machine where you can save all the SAS projects and data files in that folder. So username that's shorter than 9 letters. SAS is old school. It doesn't like longer variable names. And I'm going to use choose any folder that you want. You can put it in any folder as long as you can find them. And options, you can leave it blank. Confirm some details. And I'm going to have to check so next thing is to create data source. I'll have to check if I have, let me use the homework data set, so that when you do the homework, it will be familiar. Homework data set is churn. Great, thank you. So you already had some system created libraries. Those are typically not relevant, but they are in the system. And go ahead and find the library that you created, and then everything you put in it that's in SAS format will be recognizable. Hopefully I have churn. Yeah, I have churn. So I have already confirmed from CSV, so it's there available, and confirm some details, number of columns, number of observations, and this step. For more explanations, you can go to the previous semester's videos. I talked a lot about what they are. I'm not going to verbose here, and it's not critical. But here, this step is fairly critical. You want to specify the variables in the correct row and level. Row is in the terms of project, in the terms of the the technical use of the variable, and level is the format, the type of variable. And for most of it, SAS will guess correctly because SAS took a look at the values in those columns and figured it out. So a lot of times you didn't have to change anything, but let's see. For the first homework, it might not be necessary, but for later homeworks, you will use this data set to build a predictive model, or several predictive models. And to be able to do that, you have to have one and only one target variable. And so here, the target variable is the churn, and is the churn variable. And you can refer to the sheet for what it means by churn. It's a critical behavior variable that is of interest to to the company's marketing team to improve the marketing performances. So change the role into target, and you should be good to go. Let me quickly look at. So you can sort the variables. Currently, it's sorted by alphabetical order of the name, but to make it easier, I'll sort by level. And I can see all of these are interval. That means these numbers can range from 0 to whatever, to a large number. But for things like, let's see, for things like area code, this is the area code of the service plan. Right? This is a telecommunication company. The services here are landline phone services. So every line has an area code and has the phone number in it. and because of that, so every account should have a unique phone number here. So the unique phone number can be used as an ID column, because the unique phone number would not provide any intel to you in terms of predicting if this customer is going to churn or not. It's a random number, right, of some technical details. So let's see, and phone number will be one of these. Do I have a phone number? Yeah. So it's nominal. Great. Probably because it has some symbols in it. It has some hyphen and parentheses. So best practice would be to select the ID row for this variable. Otherwise, we may run into problems in this particular format of the phone numbers. I'll talk about more when we get there. And for all the other nominal variables, we have state, which is simply where the phone number, the account resides. Vmail plan is a voicemail plan. Yeah. So most of these look good. I can go. Are you good? Can I go to the next page? All right, and decision variable is not for now. And no sample is being created. And make sure the row is raw for at least for the first few homeworks. And it's by default, it's raw. And off I go. I have a data source. Next step will be to create the diagram. So let's see, transform. The purpose here is to demonstrate transform. It's like a canvas where you create nodes and connect the nodes into paths. And then the process will move the data source from the first node to the last node. And along the path, different operations are being applied to the data source. So that's the typical flow of the project in SAS. To create the data source on the canvas or on the transform or on the diagram, you'll move and create a copy of the data source. And now the first thing I would say for any project, first thing is to create a StatExplore to look at the high-level statistics of the data source. The StatExplore is under Explore. Connect them, and before you can look at the results, there's no result. You need to run it before you can look at the results. And before you run it, a few things to change. For Y, they're also in the previous videos. Let's see. Number of observations. So I want to turn on interval variables as well for chi-square statistics. And that's it. So then I will run.
Dr. Shah, why do you want to turn on yes for chi-squared?
So that's a statistics that this node is computing. It computes the sort of the so-called the variable worth of the different input variables that has the raw input, right? It won't compute ID, it won't compute target, but it's computing the worth of every input variable of that specific type in predicting the target. So it's telling you some intel about the high level predictive power of each of the input variables. If you leave the interval variable as no, it won't compute for interval variables. But potentially, I also want to include the interval variables as the model building process. So I want to know the variable worth of both the interval and nominal variables. That's why I include it. Why does it by default not include it? I didn't know. Can you change the default? I don't think so. Otherwise, I would have. So this is the variable worth, and it includes all the interval variables. But where do you find the missing value information? You know, scroll down a little bit. On the top, it shows high-level information, number of rows, number of, and then it for statistics, the first show for class variable. Class variable is equivalent to nominal variables, so it's the same thing for this class, at least. It shows you number of levels, right? For gender, there are 3 levels. States should be 51, and number of missing values shows 0. So that's what you report, and you can take the specific section of the screenshot to show me, right? Make sure you include the variable names and the column of missing.
The bottom section has the details of each of the variables. Wouldn't you take a screenshot of that one instead?
The bottom section?
If you scroll up too much. Up. Like, yeah, right there, that one. Up.
Here?
Yeah.
Okay, so there are some difference here. There is this small section, has 4 variables, has Intel plan, international plan, state, VMail plan, and churn, even churn. Churn is the target. This section is only for nominal variables or class variables, right? To answer the question completely, you want to answer for both nominal or class variables as well as the interval variables. The next section is interval. So it has 2 sections.
Okay, so you want to have
Both,
screenshots?
yes.
Okay.
So both parts will be the complete answer.
Oh,
Yeah.
okay.
Make sense?
Got it.
Great. All right. A good question, though. And you see more statistics in the second section because you have more statistics for interval variables by nature, right? And that's mostly it. And there are more information down below. I'll save it for another occasion. But for next one, I'm going to go to a node that's called transform variable that has a function that has a function symbol on it. It's under modify, and this node is quite magical. I'll tell you why. This node would be either the second or the third, or second or third after the data source. The first one is StatExplore. I always would use as the first analysis, and after that you can either do Graph Explorer or sometimes you use MultiPlot to generate a lot of plot of a same purpose across all the input variables, and those plots are color coded and fairly good to to review information about the overall distribution. But another one is transform variable, and by one node it gives you a lot of information and a lot of graphs. if you don't use this one, and instead you use the explore function, or I'll show you where, or if you use the graph explorer to generate those graphs, you need to click many times, and those are not saved. But this node gives you the function to quickly look at the distributions without having to generate them. You can get all of them in one node. And here's why. Once you drag and click, you can go to formula. That's a magic place. And it has several sections. So let's see. It's a little small. I'm not sure if you can see them. But anyway, let's see. So the top section shows a distribution of a certain variable, and the variable is selected in the second section. Watch what happens if I quickly go through the different variables. It quickly changes the distribution view of that, and looking at the histogram. This is a histogram or bar charts, and it shows for both types of variables and has different meanings. For interval variables, it's a histogram. It's the overall distribution across the ranges of the variable, but for class variables, it shows for the discrete levels how many times or what's the frequency of each label appearing as the overall percentage, and get a visual sense. But it's a one tool to get all the distributions to look at quickly. And the benefits of looking at histogram is to identify outliers, or identify skews, right? Or identify any other bizarre looking distributions of a variable. So let's quickly take a look. Now, account length. Account length is a number of the length of time an account has been staying with the company. So how long have you been a customer so far? And it's a very well-behaved variable. It has a mean of somewhere between 100 something, maybe days, maybe weeks. I'm not entirely sure, but I wish the textbook gives more information. But so the mean is in the center. It's bell-shaped. It's fairly symmetric, and it's fairly normal, right? So it's a very well-behaving variable, and the minimum value is 1, which makes sense. There may be some new customers who just joined and haven't been staying with the company for a long time, and there are veterans here. There are somebody who's staying with the company for a long time. But those are the tails. As you go to the bigger values, frequencies drops, which makes sense. Okay, then area code. So you see, area code has a range between 408 and 510, and even has digits. Seem to be having some digits, and 3/4 of the area codes are between 408 and 418.2. So what is area code here? Yeah. Area code is the first 3 digits of the phone number. So it corresponds with zip code, generally, but not exactly. And it's geographically clustered. The same city would have only a few different zip codes, or maybe only one unique zip code for smaller cities. And not zip codes, the area codes. And the area codes for the same state should be typically within a small range, right? Okay. Now, so what makes you think about this data set? This data set had 3,000 accounts, and they have been with the company for various length of time, and the area codes concentrate on two small range of values. So they are from the same place. That's inference, or that's a guess. And let's check if that's the case, right? And take a quick look at what other information you have in the data set. Question? Huh? Good question. Is the values look similar though?
Yeah.
They're similar. But and take a closer look at the values, the labels of the values under each bars. On yours, it's integers. It's all integers. On mine, it's decimal. It's decimal point. But for area codes, does it make sense to have decimals? So there is some wrongdoing here. You can get to try to get to the bottom of it. There's some way to customize a view of the distribution, and you can right-click, graph property. If there's one thing I need to fix about this distribution, what is it? Or if there's one thing you want to fix the most to sort of help you understand what's going on. Exactly. So if I can specify there's no decimals, then maybe there is important information to learn. So let's see, it's clearly a histogram, but with a large gap. So this is a timer for break. Let me finish this problem, and we'll take a short break. For histogram, if you want to change the way that the cutoff values are specified for the label, for the values, for the bars, you can change you can't really change the minimum and maximum because it's fixed, but you can change the number of bars that you have within the ranges. Currently, by default, it's using 10. If I change 10 to something smaller, maybe it will help. Let's see. Okay, it helps a little. It becomes more like your graph, but not exactly.
Oh, I think because he has horizontal discrete checkbox. If you it's under bins. Yeah.
Interesting. So by taking that option, very good. By using this option, it used one bar for each unique value of this variable, but still map the distance between the values, which is really great. So that one effectively removes the option of setting the number of the number of ranges that I was trying to specify. So with this option, it only shows you unique values. So what do you see here? You see 3 bars. Each bar represents one area code, and they are integer now. That makes sense. That makes more sense. A lot of data are from area code with 408 and 415, and a fourth come from area code 510. Of the entire data set, you can be sure this is the entire data set. So you may want to know, may want to confirm if where is 510, right? Where is 408? Which city, which state is it? And you can find those information online, right? I assume with your friend Google. And I think by now you have more information about zip code, but you also have some ways to go. I mean, ways to go forward. More, you have more information to find out. If you keep scrolling, turn would be a binary variable with yes or no. A lot of them didn't turn. All of them have false, right? So the majority of the customers decided to stay with the company after a year of a contract. Let's see. And if I keep scrolling, and these are the usage statistics, and most of them behave fairly well. They are bell-shaped. They are fairly symmetric and smooth, distributed with a good range. And finally, I get to this variable state, and where you see and from StatExplore, you know that there are 51 states, including the capital. So based on the state variable, this data set should be covering the entire nation. That should give you a question, right? What's going on?
415 the California codes, and seems like California is the lowest one. We have the lowest number of customers.
The fact that you see 50 states gives you big question mark.
It should
Right.
be covered
So,
more or less.
so that's where my hints go. We'll stop, and we'll let you figure out what's the best way to describe the problem, or how far can you go further? Can you go further, and how would you specify the problem?
But doesn't that mean something is like actually wrong with the data?
Could be. And don't be afraid to narrate your thoughts. And well, what you see is reality with the data set. Software is not telling you, it's not lying to you,
Okay.
right? So you're using the right tool to look at the, to answer the questions that you have. What are the area codes? And those are the area codes that you see. And how many area codes are there? How many states are there? But think about the reality. Would that happen? Would that happen, right? And compare the reality with what you see in the data set and make a judgment.
Okay.
Right. And clearly there's something wrong here about what is wrong. Or I should say this. It's never possible to specify without really, if you were the one who collected the data, you might know what really happened. You might go back and trace. But since you didn't collect the data, so you can detect a problem, you can never know what really triggered the problem. But you can at least make a judgment. Is this data set wrong enough to the point that you can't trust it? And you can hypothesize at least what is wrong. You can't specify specifically what's the cause. Right? So I've demonstrated this tool, and for this part, it's mostly for quickly exploring the data set, right? And now I'll show you how to do the transformations. It's under variables. So under train variable, why train? Because you are making some changes to the training set. So if you click variables, you have every single variable here, and there's a column from method. You have a range of options to select for how to transform the variables. And there are two options here that says standardize. And there is a standardize that there's one option that says standardize, and this means that z-score standardization, which is to center the mean to 0 and to make to rescale the standard deviation to 1. And the other range standardization is what the textbook calls min-max standardization, which normalizes the range of every variable to have the same min and max. So that's where you go. Sometimes if you want to apply the same transformation to all the variables, it's not the case here. Well, the question didn't ask you to do on all of the variables. And sometimes if there's one transformation you want to apply for all the variables, you have an option to specify the default. It's under train. There's default methods for the 5 types, for the first of the 4 types of variables. It separates by interval, type, and class, which is nominal, and also separates for input and target. You never use the same for all 4. So that's no. You never select yes to all 4. At most, you will select 1, but I would say, most typically select 1 default variable. And also you have, so for interval variables, if you want to standardize all the interval, not for target, typically don't change target to make sure you can compare different models, but you can change the input. So for the input, I would like to select z-score standardization as the default method for all the input. But there's one exception. I want to not apply the default method on one of the variable. How would you do? You select the standard, or you select the default, go to variables, and where it says default, it will use the default method according to the specific type. But for area code, I don't want to apply the default method. I should choose none. So it will be excluded from the default list. So that's a way to customize and make sure you okay. Otherwise, it's not saved. It's only these steps that you have to okay to confirm. And it's not done yet. You need to run it. And after a successful run, what's selected will be applied. Questions? That should, you're good to go, I think, for homework 1.
Thank you.
Sure, my pleasure. And confirm, confirm that it has been, changes have been applied for, let's see, for all these variables. These are the original. Because I used the default, standardization has been applied to every interval variable except for area code. So for these computed variables, their names have been prefixed with the STD, standardization prefix, to indicate what has been done on these. And the formula is listed here. And you can confirm that the formula is correct. But you won't find zip code here because it's not included. So that's it. So in your homework, if you only apply the standardization on the 2 variables, you should only see results to show 2 created variables, right? And confirm the range and standardization after transformation. After transformation, the mean should all be very close to 0, even if not exactly 0, because numerical, details. But something like that, it's close to 0, right? Does that make sense?
Mm-hmm.
Yeah. And standardization, standard deviation of 1 after the z-score standardization. And then the question asks you to generate a graph of distribution. Then where can you get the distribution? I think I just showed you earlier. You can go to transform, you can put another transform, I think, after this transform, and to get all the transformation, all the distribution of every variable, including the computed variables. You can take a screenshot and include it in your homework. Make sense? Right, so you need another transform variables node to follow that, to be able to generate distribution for the computed variables. I think that's what you need. And you can see the new variables. So that would be even better. But either way, you know you can get them, one way or the other. All right, so that's you're good for a break.
Yes.
Okay, 5 minutes.
Yes.
Okay, go use the restroom. All right, now I'll make a MultiPlot. And what David shows on the graph is the bar chart of the input variable customer service call, and color code the outcome for turn. So for the properties of MultiPlot, you want to make sure you're using the bar chart, but of course both. But for any type of variable, only one type is that makes sense. The other type won't make sense. So since I'm looking for the bar chart, I'll do the bar chart. It's making a lot of graphs, so it's taking a little time. So, okay, now you see a list of variables, and these are the variables that are input variables, and for each of the variable, it's creating a binary coloring scheme for the two outcomes. For customer service calls. Well, this time it's going to be a little bit different because accidentally I did a standardization for all the variables, and I'm getting all these standardized variables. But let's see what happens here. So so this is customer service call, and the labels look a little bit weird because they're negative. This is because it's standardized, right? But imagine for a moment that this is 1, 2, 3, 4, 5, and they still are. They still have the same shape because after transformation, the groups still have the same value, but the standardized value is still all clustered into the same group. Standardization doesn't change the actual distribution. It simply changes the scale of it. Now, so this is the graph that David shows, and by default, it also shows the number of cases under each bar. So it clearly shows you what's a portion, what is the majority of the cases. And those who make 4 or 5 or beyond number of customer service calls, they are not a large group. But definitely for this group, it's worth to dig in, and if there's good intel to show what exactly is prompting them to make the customer service calls, you have more leads to fix the problem. And beyond that, with the MultiPlot, you have generated for every variable the same type of graph, so you can simply scroll through and find what you want, right? Instead of creating one graph for every variable. Questions? Okay, and What else? You can do this. So a bar graph that Aaron did, but the thing with SAS is you can't do normalized graph where this is normalized. It shows the percentage. With SAS, it can only show the bars, which I think it's already here. So you simply go to the results and go to the international plan, and you can see and international plan is not standardized because it's a binary variable. So it's actually a little different from the results here, but within those who have international plan, close to 45% churn. Within those who don't have international plan, only 20 or 15% churn. That means international plan may have a problem that leads people to churn more likely. But another question to ask is, those who subscribe to international plan is not the same as those who don't subscribe to international plan. There may be some unique needs that international plan subscribers have that gives them more expectation or something like that. There's special needs. But those special needs are not being met or satisfied by the service. So at least gives you more directions to go. So true graphs, you can do something like this, but not in multi-graph. With multi-graph, you can't change the shape. It just makes a lot of graph for you, which is efficient, but you can't change. You can customize. To be able to do a customized graph, you can go to the Graph Explorer that gives you more tools. But let me show you quickly where you can do a lot of things. For every node, you have an option to edit variables, right? I'll go to the original data source because it's the original scale. I'll go to the edit variables. Here you can change the levels, but what you also can do is to quickly look at the distribution. If I want to look at churn and international plan, I select the two. I go to Explore. It shows the summary statistics of the two variables I selected. And here you can see the overall distribution of the two. But it's not there yet. And a good trick in SAS EM is whenever you have the graph in the same view, they are linked. The data in the background are linked. So if you click one bar, that portion of data set is automatically highlighted on all the other graphs of the bar. So this graph is almost the same as this graph, and almost the same as the MultiPlot graph, even though with different colors, but the purpose is the same. You can interpret that those who have international plan have close to 45% of churning, but those who don't have the plan, only 10% churn. So that gives you the same conclusion. Good? That's it.